In this segment, we're going to talk about circles. Now here I have drawn a circle on the coordinate plane, on the coordinate system, and we're interested in finding the equation of the circle, and eventually we would like to be able to graph these circles and find their equations given information about the circle, such as its radius and its center. So first of all, by definition, a circle is going to be the set of all points in the plane that lie a given distance from a given point. So that given point, in the case of the one I'm working on, that given point would be here. This is what we call the center. Okay, so the center of that circle is this point C. Okay, now the coordinates of this circle, the center of the circle, again, every point has an x and a y. We're going to let h represent the x and k to represent the y coordinates of this circle. Okay, and then the radius would be r, and this would be any other point on the circle. Again, the definition of a circle: the circle is the locus, means the collection of points, the locus of all points that have the same distance, like this point, same distance, this point, that are the same distance from a fixed point. See, all of these points qualify. But if I have a point here, see, that point is not on this circle because it exceeds the perimeter of the circle. It's not, it has to be on the circle. And there you go, we have a circle. So how do we find the equation of a circle? Actually, it turns out that it's not difficult. We can use distance formula. Okay, so how does this distance formula works? Well, remember, the center has coordinates h and k, correct? So if I look at another point on the circle here, xy, the distance, which is the radius, r, distance squared, is given by the x component of the point, x squared, minus the x component of the center, which is actually, I'm finding the distance. Okay, so it's going to be the x component of the point. I squared it too soon. Minus the x component of the center, then squared, plus the y component of the point minus the y component of the center, y minus k squared. All right, and that will give me this distance. Actually, that's this distance. Again, the higher point is y, the lower point, this point, is k. Remember, k is how far the point is from the x-axis. So if I do y minus k, it gives me the rise here, right, from C to the point, call it point P. Okay, and you're looking at the equation of a circle here. We don't need to take the square root often. The square root is not necessary. In fact, for circle, we don't take the square root because we don't want the distance. We want all possible positive and negative values that work in the equation. So this is what we call the HK form. The HK form of the equation of a circle. Some call it the center form or center radius form of a circle. Now, if the center of the circle is at 0, 0, then of course h and k would be 0, and we get the reduced version, x squared plus y squared equals r squared. This would be the equation of all circles that are centered at 0, 0. If the radius is 1 and the center is at 0, 0, we get a special kind of circle. That's x squared plus y squared because the center is 0, 0. And further, because radius is 1, square that is 1. And this is oftentimes referred to as the unit circle. Unit references the radius of the circle. All right, and there you have it. So let's say we to practice this one. Let's say in my example, suppose the center is given to be -3, 4, and my radius is 6. And we want to find the equation of the circle. So it's pretty easy. Once we're given radius and center, I just have to plug it into my formula, right? X minus h squared plus y minus k squared equals r squared. And x minus h, remember, h is -3 and k is 4. H is the x, k is the y component of that point. All right, so we go x minus h, so that would be x minus -3 quantity squared plus y minus k, that's y minus 4 squared equal radius 6 squared. The double on -3 makes it +3. I can finish that one here, right in front of this. So that's x plus 3 squared plus y minus 4 squared equals 36. And that would be the equation of the circle. Okay. And let's see. Now, what if we don't have the HK form of the circle? Well, the more general is a polynomial form. So let's talk about the general form of a circle. The general form of the equation of a circle is x squared plus y squared plus, I'm going to go with, again, the notation on this is different depending on who's doing this, but this is one way to do this. Why do you start from D, E, F instead of A, B, C? So where are the A, B, C? Well, A would be the coefficient here, B would be the coefficient here, and C would be, if this one had an XY term, it would be something like that. Okay, so that's why the A, B, C are missing here. Now, and D, E, and F, these are just real numbers. Okay. So this, for some real numbers D, E, and F, this equation can have a graph that is a circle, or it could be a point, or is non-existent. Okay, because depending on how the numbers work. So let's take a look and see how we're going to use this general form. Suppose I'm going to make an example up here. Let's say in my example, I have x squared minus 6x plus y squared plus 10y. And let's make the constant 18 here. Okay, so suppose I have that equation, and that's set equal to 0. Okay, now we need to, in order to go from what we call the polynomial form to the HK form, we need to complete the square in x as well as y. That means I need to get the square of a binomial in x, and I need to get the square of a binomial in y. So I group the x's, the y's together, and move the constant to the other side because we don't need it. We're going to create our own constants. Now to complete the square here, we've done this review of completing square in chapter 1. If you need to review that, please go back and look at my videos in chapter 1 or when we talked about quadratic equations. So to complete the square, if you remember, the procedure is to use half of b squared and half of b here. B is the coefficient on x. There you go. We're looking at ax squared plus bx plus c. So half of b, this is b, the coefficient on x. Half of that. And b in this example is -6. Square it. And half of -6 is -3. Squared is 9. So I'm actually going to add 9 plus 9 in here, and that should complete. What we have now is a perfect square trinomial. Now what about inside the next set of terms involving y? So for this one, again, we're going to do half of the coefficient on its b is 10. Don't forget to square it. So half of 10 is 5. 5 squared is 25. So this time we're actually going to add 25 to both sides of this equation. So here's 25 here. Now 25 on the other side. And remember the 9. We need to add 9 to both sides also. There. And once we have that, once we've done this again, because the way the numbers 9 and 25 were found, we know that this is going to be x minus 3 squared plus y plus 5 squared. And all of this should equal 16. Okay, so there we have the equation of the circle. It looks like the center of the circle is at 3, -5, and its radius is 4. Okay. Now what we need to note here is that, by the way, the radius, notice how the radius is 4. The radius is not 16. We need to take the square root of 16 to get the radius. And the reason is because in the form that we had, the HK form, you see that R is in its squared form. So R is presumed to be, in whatever number it is in its squared form. So therefore R will be the square root of that number. And there you have it. So that would be the equation of this circle. And we can of course graph it, right? If you wanted to. Let's see. Let's take a look at another example. How's that? Let's say something where we have to complete the square again. So suppose this time I have x squared plus y squared plus, let's go 6x plus 8y plus 9 equals 0. So again, what we want to do is we want to find the center and the radius of the circle that's represented by this equation. So we're going to combine, or really we can't combine, I should say group. We're going to group the x's, we're going to group the y terms together. Terms that have y in them. The number, we move them to the other side. So what do we need to add? I need to add half of 6 squared, 9. Half of 8, 4 squared, 16 to both sides, without putting the details like I did up here. See, this is the part I'm skipping over. Now, once we have that, then the binomial form is going to be x plus 3 squared plus y plus 4 squared equals, now I need to add 9 and 16 because we can't just add to one side. So there you go. I added 9, 16 to the other side. The 9 and -9 add to 0. They're opposites. So there's the equation of that circle. Now remember the form. The form is important here. The form comes with a minus sign between the x and the h and between the y and the k. In other words, if you recall, it's x minus h squared plus y minus k squared equals r squared. So we know that the radius is 4, right? The square root of the number. Now if you look at this form, you have to have x minus h. The x plus 3, let me show you just this one time how we manipulate the 3. I'm going to write that as minus and -3 squared plus a y plus 4. I'm going to write it as y minus and -4. Double negative is positive, and that's the reason. Might as well write 16 as 4 squared. Okay, so you can see now in this form, these are the minus symbols. So the h must be -3 and k must be -4. Okay, so anytime in parentheses, the binomial, you have plus a number, h and k would be exact opposite of that. For a 3, h would be -3. On a 4, k would be -4. So the center is going to be -3 and -4. Okay, and then of course we can, if we wanted to, we can graph this one easily. Let's see, let me do this. Actually, let me grab a different coordinate system that works a little better. Maybe this one. Yep, there you go. Now for this one, I want to graph the circle. So I'm going to go to -3, 1, 2, -3, and -4. 1, 2, 3, 4. So this is pretty much where the point is, right? That's the center. Now to graph this one, because radius is 4, and remember that means in all direction the distance to the circle from the center has to be 4. So I'm going to go up 4 units. Remember, I'm at -4 here. Okay, I'm at -4. So I'm going to go up 4, and then I'm going to go down 4. 1, 2, 3, 4. These are like the boundaries of the circle. And then I go left 4. That's 1, 2, 3, 4. And then right 4. 1, 2, 3, 4. And the circle has to actually go through these points. Okay, so I'm just going to grab a circle and see if I can fit it onto this so it looks nice. Okay, and there is the circle. I just drew it, make sure it's kind of circular because I'm drawing it by hand. And there is the graph of that circle. Now, let's do one last one. In this next one, what if the coefficient on x squared, y squared, what if the numbers in front of those are different from 1? One thing for sure though, those numbers must be the same in order to have a circle. Okay, so if this is 4x squared, I cannot have 6y squared. They have to be exactly the same. Positive, negative, doesn't matter as long as they are exactly the same. Now the other numbers on those terms could be different. So let's say I want to work with this one. Again, we want to find the center and the radius of this circle. So I'm going to group the x terms together and group the y terms. Actually this would be 16y. Otherwise, like just two numbers would have combined. It's got to be, we got to have a y in there for this example. That's 4y squared, and this one became 16y. There. Now everything looks good. Okay, so the coefficient, notice the number in front of x squared is 4, not a 1. So what do we have to do? In this case, we need to factor whatever this number is. Let's factor it outside. And once we factor it, we got to factor on y squared, the 4. Oh, the 19, the 19th. Let's see. Let's move that to the other side. Equals 19. Negative on the left becomes positive on the right side. Now, what do we add inside parentheses? Remember, half of the coefficient on x, that's half of 1, and then you square it. So half of 1 is 1/2, squared is 1/4. So that's plus 1/4. Plus, in this one, half of 4, the coefficient on y. Half a coefficient on y, 4 is 2. 2 squared is 4, so we're going to add 4. Now, got to be careful. What do we add to the other side? Well, it looks like we added 4 here, and looks like we added 1/4 here, right? However, because of the numbers that are outside parentheses, remember, those distribute themselves onto the parentheses. So we do need to take that into consideration. So I'm going to distribute first. 4 times 1/4 is 1. So I'm going to add 1 on the other side. 4 times 4 is 16. I'm going to add 16 to the other side. So please be careful. Don't add what's in parentheses. We did up here, right? We added 9, we added 16, added 9, added 16. And the reason we didn't have to do that here is because these coefficients on x squared and y squared were 1, see? 1 times 9 and 1 times 16. So for that reason, we didn't have to do this, what we're doing now, to the previous example. All right, looks good. Here's 4 on the outside. And then we go x plus half of 4 is half of 1. Half of 1 is 1/2. That's what goes inside the parentheses in the binomial, you square it, plus half of. This would be y plus 2 squared. And on the other side, we got 19 and 16, 35, and 136. Perfect. And the last step, is to divide everything by 4. Because we want to get the binomial by itself, no number before it. Plus y plus 2 squared equals 36/4 is 9. And there you go. That is the equation. So the center is going to be, remember, opposite of what it seems to be here. -1/2 and -2. And the radius will be square root of 9, which is 3. And there you have it. We have the equation in the HK form, and we identify the center and the radius of this circle. Okay. So that should do it for this lecture. And as always, thank you for watching.